Let's come to Science 4. And to understand that here on the verge of 2008, our capacities are about to jump again onto an extraordinary scalar. And this learning, this pattern of maturation, indispensable already for what has occurred, and this next level is extraordinary. The current issue of Nature, the International Journal of Science, has a cover story on attosecond real-time photography. Attosecond is the atomic level of action. And attotron transport in real time. So we're moving out of the realm where everything had to be mathematical and probabilistic, stochastic processes to even understand subatomic levels of activity. And it's been now about 20 years since over at Caltech, the great Ahmad Zewail from Alexandria, Egypt originally, developed femtochemistry, the ability to see molecular level action real time. Attosecond is a whole echelon more detailed, to be able to see atomic processes, subatomic processes, to be able to see electrons in action. Our capacities have been stretched beyond the incredulous since the 1890s. And some of the developments of the 1890s we have talked about. The most conspicuous for the general public is the development of H.G. Wells' science fiction in the mid-1890s. When he published The Time Machine in 1895, it caused a world-wide recognition of wonder. And he followed it up the next year, 1896, with The Island of Dr. Moreau, of being able to change animals into primitive, primordial human beings. So that time now was something that could be broached, species could be broached. And the next year he wrote and published War of the Worlds, and then The Invisible Man, and then First Men on the Moon. And by 1900, in the space of just 5 years, in H.G. Wells's presentation alone, you had the new century greeted with an incredible realization that we were on the verge of something enormous. And then in 1905, Einstein came out with what they call a miraculous year, the special theory of relativity, the work on randomness, Brownian movement, etc. But 1897, right in the midst of this, was the discovery by J.J. Thomson of the electron, a subatomic particle for the first time, that the coherence of the pinpoint foundation, the atomic theory of materia and matter, was shattered forever. And very soon after that, it became possible to be able to begin to understand, because by 1905, Einstein had predicted that there would be a particle, not necessarily in an atom, called the photon, which would be the carrier of light. And it turned out by 1923, when Arthur Holly Compton found the proof of the photon, it was evident that we had come in one generation to a watershed, and right in between the prediction of the photon by Einstein and the confirmation by Compton in experiment, cosmic ray experiments, was the theory and development of the proton as the center of the atom, as the nucleus, by Ernest Rutherford. He posited in 1911, and he was a little leery about really putting it out, and it was Niels Bohr who, at the end of 1912, made arrangements to leave Denmark and go and study with Rutherford, who had done a lot of his work at Cambridge University, but had gone to the university at Manchester, England. And it was there that Rutherford and Bohr came together. And by 1913, the two geniuses, surrounded by a number of other, one could hardly call them sub-geniuses, but not quite as great as those two, had come to understand something that was so devastating. It was held back, except for just a handful of people, because World War I broke out, and the entire fabric of Western civilization tore. And it kept tearing all the way through 1918. And it wasn't until 1919 that finally the miniature solar system model of the atom, having a central nucleus sun, a proton, and orbitals, the electrons, obviously in multiples, in shells, was understood well enough to make the 1920s a truly hyper H.G. Wells decade that was transcended about 100 times by the 1930s and was blown out maybe 1 million times by the 1940s, so that by mid-20th century, by 1950, it was apparent that we were running scared, out of control. And part of the paranoia, the nightmare that descended upon the world at that time, was the Cold War, really in force. And for those of us who were alive at the time, I was a child of 10, I remember the disappearance of the beloved superhero comic books, Big Little books, and so forth, and the appearance of little sets of GI soldiers for the Korean War, and comic books changed. Now you had to have a comics code that edited what little children could read and purify it so that they didn't get not only the gutsy quality that comics in the late 30s and early 1940s had, but the fabulous layer upon layer of esoteric understanding. Perhaps the most key comic book superhero of that era was Wonder Woman. And if you get, I will bring next week a couple of early issues of Wonder Woman, issue number 3, issue number 10, from the early 40s, and read you the inside cover of all of the major people who went together to put their talents to make this superhero deep into the ancient mythology, deep into the Renaissance psychology, and to open it up to the possibilities of a trans-science fictional wonder for the future. And they were very conscious of raising a generation of boys and girls who would be able to go into the new world of unlimited challenges and peril with unlimited promise and capability. And it was that generation of boys and girls who did something no human beings have ever been able to do and have not been able to repeat even 50 years later. They went to the moon comfortably. One of the most impressive works that came out in the mid-1890s, and this is a reprint translation of it, by an Italian named Tullio Levi-Civita, professor of rational mechanics in the University of Rome, and it's called, in English translation, The Absolute Differential Calculus, parentheses, the calculus of tensors. This is the 1926 translation by Miss M. Long of Girton College, Cambridge, and we read in one of our books, Kip Thorne, Einstein's Outrageous Legacy, Black Holes and Time Warps, this little paragraph. A few weeks after discovering space-time curvature, Einstein moved from Prague in the Czech Republic back to Zurich in Switzerland to take up a professorship at his alma mater, the ETH, the Technical Institute, that had been reformulated there. And the ETH is extremely powerful. Two of the early professors in the 20th century who got together from there are Carl Jung and Wolfgang Pauli. And it's the combination of Wolfgang Pauli and Carl Jung that developed the whole idea of synchronicity. This is a little a couple of pages, 4 pages on synchronicity by F. David Peat. Synchronicity, the bridge between matter and mind. And it is a deep quality. David Peat is the editor of a lot of the work that was done by David Bohm, and their work together, Science, Order, and Creativity, came out and became a bestseller some while ago. The bridge between mind and matter, not only presented in synchronicity, presented in a masterful book by Bohm called Wholeness and the Implicate Order, was a synergy between the two figures that we're looking at together, Einstein and Niels Bohr. And the synergy was an almost impossible thing to do because they did not fit, and for a long time were considered to be incommensurate, alternate theories. David Bohm's first really great professional book was on quantum theory. Bohm at this time was a professor at Princeton, and the first edition, 1951. And his book on the special theory of relativity came out later. This particular edition is published in 1964 in England and 1965 in the United States. Bohm was a professor of theoretical physics at Birkbeck College in London, University of London. And the synergy of quantum theory and the special theory of relativity between Niels Bohr and Albert Einstein was attempted by David Bohm in Wholeness and the Implicate Order, and we'll talk about this a little bit later. But what's interesting to us here is that the ETH in Zurich at this time was a particular focus, and one of the creative triggers for this was the young Einstein. He went back from being a professor in Prague for a very short time, less than a year, and in August of 1912, he was back at the ETH in Zurich. And as we were pointing out, one of the peculiar things about Einstein is that he was not, first of all, a mathematician. He was not actually, first of all, a physicist. That to really understand Einstein, we need to characterize him as an outlaw artist. He could not stand authority of any kind. He could not understand how he could be folded into previous conceptions and previous expectations, and all of this made him an outlaw. But as we have been showing the last 3 presentations, the focus of his frame of reference, of his square of attention, was a series of 4 aspects, 4 sides that began with experience, which we have come to understand is the mythical level, went to an integral with symbols, went to a transcendence, transform with vision, visionary consciousness, which is differential, not integral, and came to its square of attention with art, which is a personal expression, a personal form, but not a form like symbolic form, which is in the mind and is an integral, but artistic form is a prism of consciousness, not a mental phenomenon at all, but a consciousness noumenon. Works of art are numinous, they are not phenomenal. An artist is a noumenal person, not a rational individual. And there's a great deal of difference. And in between the symbolic individual and the artistic person is a field of consciousness, of vision. The ancient name for it in Greek is theoria, and that's where theory takes place. The rationalist who is mentally bound will automatically consider that theory is a function of his mind. And this is not true. Theory occurs in the field of consciousness, and that field of consciousness has a coextensive, expansive, dimensional spread as nature. Nature is a field. It is the relationship between the field of vision and the field of nature that allows for a theory of synchronicity, of a relation between matter and mind. But the matter that comes out of nature comes into unified existentiality. It becomes something. It becomes a particle. And the particality is a direct registry of integral unity that has emerged out of the field of nature. And one of the characteristics is that it can keep relating, and that each unity related together makes a further higher order of unity. So that while there may be a proton and an electron, they can come together and they can make an atom of hydrogen, which can be more complicated. One can have 3 different states of hydrogen. And we talked about last week of 3 different energy levels of the electron. The muon, the tau particle. Even though the muon was found by 1937, it wasn't until the late 70s, early 80s that the tau particle was found here in California at Stanford. So all of this is recent and accumulating, and at the core was a group of just a handful of people around 1905 to 1913, presaged by an even smaller pioneering group from the early 1890s to the early 1900s. Einstein was the outlaw artist trigger for all of this. And one of the great senior scientists at the time was in Belgium. His name was Lawrence. And this is a collection here, Heinrich Lawrence. This is published in Leipzig, but in English, The Theory of Electrons, 1909. Very early on. Its application to the phenomena of light and radiant heat, a course of lectures delivered at Columbia University in New York, which is why they're in English, in March and April of 1906. And already, by this early date in the preface, Lawrence writes this: "Nevertheless, there are several highly interesting questions, more or less belonging to the theory of electrons, which I could but slightly touch upon. I could no more than allude to a note to Voigt's treatise on magneto-optical phenomenon, and neither Planck's views on radiation nor Einstein's principle of relativity have received an adequate treatment." And we've talked about how the development was so precarious that almost no one was able to deal with this activity. And so in Brussels, a whole series of conferences were arranged by a wealthy industrialist named Ernst Salve. And this is a history of the Salve conferences by Jagdish Mehra. Salve, who was born in 1838, he lived until 1922. The first Salve conference is in 1911, right at this date. And seated at the center of the table, of course, is Heinrich Lawrence. And by the time that you get to the seventh Salve conference, the person who's seated at the center of it is young Albert Einstein. He was not just a genius among geniuses, he was radically different from everyone else in the field, except for someone like H.G. Wells. And the reason is this: Einstein and Wells were artists. All the rest of them were either symbolists in the mind or theorists envisioning. And Niels Bohr was the greatest of all of the theorists. Now, a theorist, that square of attention that a theorist has is radically different from a symbolist. The archetypal, by now, archetypal symbolist was Sir Isaac Newton. And Newton completed the integral frame of reference, the integral square of attention. He took it back to its base in nature, developed it into the rituals of existence and action and sequences and that order, the way that generates experience and language and images and feelings and experience, and the way that that is finally integrated symbolically in the mind. And Newton's great work, Principia Mathematica, 1687, is held as the all-time great model of the completed square of attention of all four corners of all four stages of the way in which one looks realistically at how we understand, beginning through nature, into the mysteries of existence, the complexities of experience, and the order of the mind, in which case now one has a complete understanding, and it was called at the time the clockwork universe. Tick-tock. It works like that. And one can figure it out to the nth degree, and hence the word is, one now knows the mechanism. One knows the mechanics. And out of this comes a whole sense that there is a mechanics to the universe that can be rationally understood through symbols, and that math are the symbols in the mind that will understand this. This whole understanding is based upon a theoria of rationality that dates itself back to 300 BC, back to Euclid's Elements, the basis of plane geometry. But Euclid's plane geometry was blown out of the water, and nobody knew about it in the 1860s, and the man who did that was named Riemann. And here, L.P. Eisenstadt from Princeton, 1926, Riemannian Geometry. And it is Riemann's geometry that's the beginning of a whole transformation, that traditional geometry is a habituation to ritual that, as a referent for symbols, destroys the whole imaginative range that is possible. So out of this comes eventually a classic work like this by David Hilbert and one of his co-workers, Geometry in the Imagination. Central to this is the transform that was brought into play in the 1890s by Tullio Levi-Civita, the absolute differential calculus. That while you have, and this is going back now to where we began, this sentence from Kip Thorne's Black Holes and Time Warps. Zurich, Einstein, 1912. He then sought advice from an old classmate, Marcel Grossmann, who was now a professor of mathematics, and Einstein explained his idea that Newton's tidal gravity idea actually is better expressed as space-time curvature. How is there any mathematics, are there any sets of equations that are able to deal with this, able to talk about it, able to express it? Grossmann, whose speciality was other aspects of geometry, wasn't sure, but after browsing through the library for quite some while, he came back with the answer, yes. The necessary equations did exist. They had been invented largely by the German mathematician Bernhard Riemann in the 1860s, the Italian Gregorio Ricci in the 1880s, but Ricci's student Tullio Levi-Civita in the 1890s and 1900s, they were called the absolute differential calculus. Or in the physics language of 1915 through 1960s, tensor analysis. Or in the language now from 1960 to the present, the book was published in 1994. It was called Differential Geometry. It's like in our work, the previous integral of education, of learning, has been out of date for at least 2,500 years. The only people that ever knew this were savants, were seers, were wisdom geniuses, were special men and women who excerpted themselves, like an Einstein, from the expectations and the authority and the pecking order made so necessary because you cannot get an adequate job. You can't get a fulfillment of your social position. You cannot get by unless you fit in. Whereas the expansion beyond the frame of reference that has the expectations and authority of the world leads you into other worlds. And the difficulty with other worlds is there isn't just an other world. That other worlds is an infinite plural. This is a very deep challenge. because in an integral, you can characterize everything by 0 and 1. With that kind of a binary, one can come to express everything that modern computers express. But once you leave that frame of reference as a square of attention and you add a fifth dimension of consciousness to it, in vision now, the binary, 0 and 1, is no longer the operative reality. The operative reality is now a binary of 0 and infinity. And to the symbols-centered individuality of a mentality, this is something scary. Because there's no end, there's no boundary, there's no parameter. How then do you have shape? And it's the artists that come through and say the shape now belongs not to boundaries, but to resonances. It is the resonant sets that convey now the sense of order, and that what gives resonant sets their higher sense of order is harmonics. So that if one has a harmonic of resonances, you now have the ability to not have sound organized rationally in an integral square of attention. You now have infinite musics that can be appreciated. And so the understanding moves from the need to fulfill an expected certainty to the broader tolerance that there is an appreciation and an analytic that can extend the appreciation indefinitely, so that the arts and sciences now belong to a higher realm, an ecology that adds to the circle of nature. And the ancient way of expressing this is that that circle of nature and this circle of higher facilities and capabilities coming together make an infinity sign. And that infinity is explorable indefinitely. What happened is that Einstein was suddenly appreciated after the first Salve conference, and he was invited to become a professor at the University of Berlin, one of the great prestigious, the Harvard of Europe of the day. On a par with Oxford, on a par with University of Paris or the Sorbonne, or Cambridge. The University of Berlin was that in 1914, Einstein went there and stayed there until he was finally driven out by what politely is called the National Socialist Party, the Nazis. But already by 1930, Einstein was starting to travel in the United States to go to places like Caltech here in Pasadena. And the president of Caltech, Millikan, who was himself a great physicist, his book on the electron plus and minus very early on was one of the classics. He was now the president of Caltech and had set out to make Caltech on an equal to the development of Princeton and the University of Chicago and Johns Hopkins University, all of them seeking at this time to raise themselves up to be on a level with Harvard. You can include UC Berkeley in that, and later on the new young Stanford. By 1932, it was apparent to Einstein that he was not going to ever go back to Germany. He hated not only the Nazis, but the whole capacity for intelligent population, immense population of people, to be silent or to accept what he saw as absolute madness, which it is, was and is. He stayed in Belgium for a year, and then finally he left on a ship, and they were caught in a huge storm going into New York, and Einstein was one of the few people who was able to stay on deck. And he remarked, he said, "I'm so glad to see that Mother Nature can still make everyone afraid and put us back into a humble position where we're praying that we can get ashore." He never went back to Europe. And so increasingly, Einstein limited himself. When he came over at that time, he dressed like a dandy, smoked his cigars, had his brandy, loved the ladies, and increasingly, Einstein as an outlaw artist became more and more like a master surrealist, like a Max Ernst or like a old Matisse, and limited himself more and more until his little two-story house at 112 Mercer Street on Princeton's campus had a nice long walk through open quad lands to the Institute of Advanced Studies that had been set up by Rockefeller funds in the early 1930s, especially to place as a magnet the geniuses having to retreat from Europe to have a place, at least a way station, that would be comparable to Caltech or Harvard or any other place in the United States. And so the Institute of Advanced Studies had its star figure from 1933 on 34 in Einstein. And it became the icon of the brilliant outlaw who understood the universe better than anyone alive. And when I was a boy in the 1940s, there were three human beings that were considered exemplary, and Einstein was one of them. Gandhi was a second, and Albert Schweitzer at Lamborghini in Africa was the third. That Schweitzer had camped out on the edge of the primeval forest, washed his hands of the limited European civilization, and lived African. Gandhi, who lived then Indian, and Einstein, who lived a solitary genius on Princeton's campus. And until his death in 1955, Einstein was always considered the poignant spirit of future man, and that if we could only find out about Einstein's brain, we would be able to figure out how to have brilliant boys and girls. It isn't figuring out Einstein's brain, but it's appreciating his art. Just like appreciating Bohr is appreciating his theoria, which, because he was always called Papa Bohr, he was able to take especially crowds of brilliant young men and have them family, and to understand no one is the genius here, but together our community is the genius. Let's take a little break. Let's come back from our break. We're looking at Einstein and Niels Bohr, and we've talked about this DVD from Nova on Einstein. This is the great play, Copenhagen, that features a meeting in 1941 between the Nazi nuclear genius Werner Heisenberg and Niels Bohr, and Bohr's wife Marguerite, played here by the beautiful Franziska Annis. If you remember the David Lynch film Dune, she was Paul's mother, quite an extraordinary actress. It is a peculiarity that Bohr was at the center of a group of people, mostly men, sometimes women. Bohr had 5 sons, so he was used to having a lot of young men around him. And he was also brilliant enough that he could still be the papa in a family of about a dozen young men who were at least the equal of him in terms of genius. Wolfgang Pauli was a part of his group, Erwin Schrödinger, and Werner Heisenberg, when they were all young and together. And what Bohr set up was the Institute of Theoretical Physics in Copenhagen, which was for a time the greatest collection of intellects in the world about physics and math, until they all moved to Princeton, to the Institute of Advanced Studies, or to Caltech. Bohr was an extraordinary individual, as we have seen. He was born across the street from the Danish Parliament. His family were famous in Denmark for generations, and he was always given a kind of a differentiality and treatment which he never took advantage of, but always tried to be illustrative within that and to share that. And in this way, Bohr became increasingly the figure who would speak forth. And towards the end of the 1930s, it was Bohr who first spoke up to the need for an open world. He convinced Einstein to do something uncharacteristic for him, to involve himself and write a direct letter, as Bohr had written a direct letter to Franklin D. Roosevelt, the President of the United States, who at the time was the most comprehensively powerful figure in the world. Not Churchill, not Stalin, not Hitler, but Franklin Delano Roosevelt. It was under FDR that not only was Germany beaten and the Imperial Japanese beaten, but the whole world of strategic post-World War II was being redone in a way which was going to be characteristically American, and it was the premature death of FDR that sent that entire strategy into a wobble. It lost its spin, it lost its torque. Initially, not because there were just bad people, there are always bad people, but because the leadership fell upon Harry Truman, who was not a bad man, but he didn't know how to fill the shoes of FDR. One of the last photographs of FDR at a great conference in Europe shows Winston Churchill on one side and Joseph Stalin on the other. And they are both tough guys in their own way. But FDR, seated in the middle, is like an ancient magus with his cape, near death, still trying to handle a world where atomic bombs were now a reality, and where Einstein and Bohr had both written to him that human civilization cannot function ever again on the basis of the past. And one of the deepest qualities in this is that the past, in order to be a source, now needs to be a new past. And it is a question of rewriting history. It is a deeper thing than questions and answers of challenge and response that was the best that could be put forth until this new era of challenge came upon us. It was apparent by the early 1940s that we were not alone, that this planet is not the only planet with a civilization, and that there may be star system civilizations beyond belief, beyond ken. And unfortunately, that entire aspect, which had been an open visioning aspect from H.G. Wells through the 1940s, by 1949, there was again, like those of us who had been raised on superhero comic books or Walt Disney comic books, suddenly noticed that the toys were different. The comics were different. There were no more of the classic Big Little books. There was also a sea change in the way in which the United States began to comport to the world. And one of the most indelible marks was that by early 1949, the United States space program was all ready to put a satellite into orbit. Multi-stage rockets, the WAC rocket on top of the Corporal rocket was able by early 1949 to go 250 miles up. That's higher than the space station, International Space Station, has its orbit. That whole program, characterized as MX in top secret, was canceled suddenly by James Forrestal. And within a couple of months, James Forrestal, the Secretary of Defense, committed suicide in a radical way, running out into the street saying, "They're really here," and massive insanity, committed suicide. For those who have seen the film Roswell, you know that post-Roswell, one of the recovered, hospitalized, captured aliens was seen by a group of people called the Majestic 12, and the head of that was James V. Forrestal. And the telepathy between the alien and Forrestal frightened him because he realized that all of this was true. This education, this maturation, this learning collects the entire heritage, not of the globe. The globe is an authoritarian control term to keep us global, but on the globe, on the surface of the globe, is distinctly threatening, as opposed to a planet, a planetary culture, which then becomes interplanetary in its resonances and becomes harmonic in terms of star systems. So our maturation is a maturation that is so deep, so comprehensive, that the last time our species faced this scale of crisis was about 2,000 years ago with the formulation of the Roman Empire, the Roman Imperium. Not only was the phrase, "all roads lead to Rome," but all wisdom is with the Roman state. And pursuant to that, a structure was built in Rome on the banks of the Tiber, north of the Forum, where the Via Flaminia comes in from northern Italy, just like the Via Appia comes from southern Italy. And right at the city wall and gate was built the Ara Pacis Augusti, the temple of eternal peace of Augustus Caesar. Across the Tiber is a little short bridge that leads to Castle San Angelo and the Vatican. And it's there at the Ara Pacis Augusti in 9 BC that already Augustus was sealing the world from fear, and the price of the security was that all authority, including all visionary and occult learning, is now outlawed by the Roman state, especially any prophetic writings, any oracular writings, and especially that really deep, ancient, Orphic, Pythagorean quality of visionary writings, it became illegal under penalty of state death to possess any kind of prophetic writings that were not to be outside of the keeping of the Temple of Eternal Peace in Rome. It's going to be the only repository for these kinds of things. It is in 9 BC that Jesus was born, exactly at that same time. And immediately had to have his dream master, Father Joseph, shepherd the family, not only out of Palestine, but shepherd them to a secure place in Egypt, which was to keep traveling in an ancient pattern of travel. And my work on Jesus in Alexandria is now about 30 years into expression, many volumes and books. What became important was, for Einstein and Bohr, they realized that symbolic mentality as a completeness was able to be transformed several times over. The first transform comes out of visionary consciousness, which is not integral at all, but is differential. And thus, the whole development, as we saw before the break, of an absolute differential calculus is that one now can have a calculus that is taken out of the limitations of the integral. Calculus was a high mathematical technique pioneered by a pair of individuals at the same time, Sir Isaac Newton in England and G.W. Leibniz in Germany. The impetus for Leibniz was that he was at 20 years old in Amsterdam talking to one of the great outlaw philosophers of all time, Spinoza, who was ostensibly Jewish but was not accepted in the Jewish community because he had visioned beyond the bounds of the Torah, beyond the bounds of the rabbis and the rabbinate, and had seen that there is a whole cosmos of possibility that is open, and that surely God is much greater, much wider, deeper, higher than anyone had realized. The young Leibniz, a genius, math genius, came to visit him, and Spinoza, because of his searching on the deepest level, had come across a translation from the Chinese by certain Jesuits, and even though he was ostensibly Jewish, he brought the first translation of the I Ching into a European's ken, and Leibniz is the first European to read the I Ching with a mathematical comprehension. This was in 1666, and he wrote a short book on the mathematical genius of the primordial Chinese people. A translation of it appeared by the University of Hawaii Press in translation about 20 years ago. It's about 80, 90 pages. On the basis of the I Ching, of Tao and Te, of 0 and 1, as a binary that works together, Leibniz developed calculus, the infinitesimal calculus of how to compute mathematically the infinitesimal stages, points in between 0 and 1, so that from 0, approaching 1, one can have an infinitesimal infinity of actual locations of understanding of points in geometry, in algebra, in symbolic ordering. And from 1 approaching down to 0, you can have the reverse of that infinitude. And so calculus can operate incredibly refined, and at the same time Sir Isaac Newton was developing another way of saying the same thing, another notation of calculus, through his genius and through his great mentor, Sir Isaac Barrow, at Cambridge, Trinity College. In connection with his work on optics, though it wasn't published until 1704, his first work was on the way in light through a prism will fractionate that light into a rainbow, and there must be a way of understanding how this is possible to have light arrayed in rays of colors, and that the color array of the prismatic diffraction of light is a key, like an occult seeing into the structure of not only light, but into the structure of seeing, and thus into the structure of thinking. And it led to Principia Mathematica, where he developed his own calculus, his own notation. He called them fluxions. You deal with the flux, but you deal with the flux infinitesimally accurate. All of a sudden, from the 1860s through the 1890s, up until the early 1900s, you had all of this not just challenged, but expanded into an absolute calculus that was able to take vectors out of the limits of the frame of reference and to graph them, instead of a frame of reference, to graph them with the frames brought in, so that you had a crisscross. Now you had 4 quarters, 4 angles, and if you took one of those angles, you had a graphability of vectors of development infinitesimally, and now you could expand calculus to something that is a differential calculus rather than just an integral calculus. And one can now look to infinity, approaching infinity, with all the accuracy that the math had achieved in the previous couple of centuries. It opened everything up. Einstein was the first person to have 2 individuals who were friends, who were right on the verge of changing everything. One of them was named Minkowski, and the other was named David Hilbert, and they were friends. They were at Göttingen, Germany, the math university capital of the world at the time. Minkowski had understood that there's no way to deal mathematically with time and space separately, adequately, in a new kind of calculus range, and so he put them together and was the first to conceive of a 4-dimensional space-time. David Hilbert was one of the greatest math teachers of all time, and his books on geometry, many different ones, are classics. And this theory of algebraic number fields was first published in 1897. He's the one that said of Einstein when he read his work on relativity, he said, "You know, I wouldn't believe that Einstein would be capable of this. Every university grad on the street knows more about math than Einstein, and yet it's Einstein who did something with what he knew that nobody had ever done before." And increasingly, Einstein found that he worked best as an outlaw artist outside of the group, by himself. And now we have to return back to our phases, because it's the first time that anyone has been able to characterize this in such a way that you can understand the steps of the scalar of the, not the revolution. This is deeper than a revolution. The best word for it, colloquially, so as not to scare anyone, is a recalibration. Newton's frame of reference began with nature, went through ritual, went through myth, culminated in symbols. Bohr transformed that, so he didn't begin with nature, he began with ritual and went through myth and went through symbols into vision, into theoretical vision. Einstein distilled that transformation one more time, and he began with myth, went through symbols, went through vision into art. So that Einstein worked as a lone artist, Bohr worked as a theorist, and Newton worked as a master of symbolic order. What we're looking at here is a transformation that goes one frame further to go into the process, the kaleidoscopic process of history. That kaleidoscopic process of history is what is generated by the prismatic creativity of spiritual persons and artists who are a whole order of transform of consciousness beyond the limitations of the world, and yet are a further refinement beyond that field of visionary consciousness into like a six-dimensional prismatic form of themselves called the spiritual person, called the artist of one's own life. And when one is an artist of one's own life, it can be beautiful several times over beyond belief. You're not limited to expectations. The criticisms that eat away and destroy the lower orders become critiques that help refine the artist, help refine the art. And the more the range of refined critiques, the more refined the artist becomes. The old Matisse was so refined that when he couldn't, at 80, hold a paintbrush anymore, he used to strap it on to try and paint, and he couldn't, and he was in a wheelchair, and he couldn't do much. So he had them bring big colored sheets of paper, heavy paper, and a big French shears. And he would sit in his wheelchair with his hat, his little cigar, his brandy nearby. They don't drink milk. And with scissors, without anything else, he would cut free forms out of the colored paper and have those then put up against a wall. And the late Matisse work like this is unbelievably resonant because it takes primordial colors in free form shapes and makes a relationality that is incredibly presentational in its harmonic. And the late Matisse, of course, like the late last years of Monet, took art to levels that go beyond art. They go into what we call the cosmos. They become cosmic. Science is the study of that cosmos. Symbols are the ordering of a unity, but in the cosmos, there are universes beyond number. All kinds, all colors. And so a being who has come through the distillation of visionary consciousness and through the prismatic experience of their own spiritual person and art of living, now comes to a flow called history. And history is not a dead record of the past. The stream of experience becomes a whole delta of a massive river complex in history. One of the difficulties for Sir Isaac Newton is that he could not get history right. He couldn't understand it because he didn't have the art to be able to engender the historical kaleidoscopic consciousness. His last published work is called The Chronology of Ancient Kingdoms Amended, dedicated to the Queen, Queen Anne, 1727. That's as far as he got. From the first memory of things in Europe to the conquest of Persia by Alexander, the 376 pages, it becomes eerie. The last chapter, but one of the last section, is a description of the Temple of Solomon. Because the Temple of Solomon becomes the focus of a whole occult group throughout history. Now, currently, the concern is to rebuild the Temple Mount. There are 3 big plates in the original. This is a smaller reprint done in 1988 of the Temple Mount, its architecture. And it is like taking the design of ancient Israel, which originally is there in the book of Ezekiel, the last chapters of Ezekiel, trying to come out of the exile, shape the promised land, or the deep symbolic shape of how that is to function in the Torah, the books of Numbers, Leviticus, later Deuteronomy, the last of Exodus, is all about how one portions all of this out. And the last Dead Sea Scroll from the Masada generation, the Temple Scroll, matches the Temple Mount. But eerily, the last chapter of Newton, 1727, is the chapter on the Empire of the Persians. The Persians are Iran. So that you have a quandary, because there was no way for Newton to understand the significance of Solomon and to be able to understand the significance of Iran. It was not possible for him. It was not possible for any European at the time to understand either of them. The theological manuscripts of Newton were published in 1950 by Liverpool University Press, and the last great study of Newton is called Sir Isaac Newton's Daniel and the Apocalypse. Sir William Whitla, Emeritus Professor, Queen's University, Belfast, published in London, 1922. Newton could not understand how the book of Daniel and the Apocalypse of St. John, the book of Revelation, fit together with the prophecies of Ezekiel. Could not ever get it right, and because he didn't have the vision, he didn't have some, and he didn't have the historical kaleidoscope. And so he had a science that was limited to an integral. And most mentalities in the world today are still there. There are integral teachers, integral yogas, integral this and that. There's a whole department now set up by Ken Wilber, I believe, of integral studies at JFK University. All of this is at least 100 years out of date. But in terms of the wisdom tradition, it was out of date as long ago as contemporaries of Ezekiel, Pythagoras, the historical Buddha, and Lao Tzu in China. Those 4, just to list major ones, 2,500 years ago already understood. Vision is not a place in the mind. It is like a halo of conscious space outside of the mind. It is a further dimension. And to symbolize it, one can put a halo. But now the halo would be infinity side. That bubble of holiness, that extra space, is a dimension of a field, which is like the field of nature, the field of consciousness, which, like nature, is able to emerge, but whereas nature emerges existential phenomena, the field of consciousness emerges personal noumena. The person really is someone. A work of art really is someone. It is quite possible to look at a Rembrandt and to see Rembrandt, to understand and feel, if it's lit right. There was a wonderful case of this at the Getty a number of years ago. My great friend from Norway, great artist Jan Sather, and I went to the Getty show where they were showing off their Rembrandts. They had 2 new Rembrandts, and they had them misdisplayed and mislit so that you couldn't see in Rembrandt ways. They were shown as if they were prized objects in a shopping mall. A Rembrandt painting is not an object in a shopping mall. It has its own interior light calibrated by the palette of the colors which go from gold to brown, from the earth to the sun. And if you calibrate the way that you're seeing with Rembrandt eyes, all of a sudden this little work that looked like, well, this is clearer than a photo of it, all of a sudden is a living presence. A work of art presents the artist in a resonance. There's no way one has learned to hear Mozart's Eine kleine Nachtmusik and not hear the incredible, elegant playfulness and deep mysteriousness of Mozart himself. One of the great paintings of the 20th century by the great surrealist Dorothea Tanning, who was the wife of Max Ernst, is called A Little Eine kleine Nachtmusik. It's a fantastic painting. The work of art, like the spiritual person, presents a prismatic jewel of not only who they are, but who they have been, and all the varieties of who they can be. And so they are an array of a super rainbow. If Noah got a rainbow covenant to restart humanity, our new rainbow covenant has millions of colors of possibility, and everyone that we meet is that infinite prismatic. There are more things to discover about each one of us than we have life long enough to appreciate and to celebrate. Why truncate it? And so a new quality comes out. Newton and religion was the subject in 1996 here in Los Angeles of the William Andrews Clark Library, a whole program. The Clark Library is associated with UCLA. An excellent group of people, and Peter Ryle, R-E-I-L-L, a friend of mine, is the director of that. He's the one that I was working with to try and get the Manly Hall alchemical library transferred to safety in UCLA when everything was falling apart at the Philosophic Research Society. And we got to the point of having everyone in my living room, including Mrs. Hall, who then suddenly realized that it had to do with UCLA, and she had had a bad experience with the Jules Stein Eye Institute of UCLA, and she nixed the deal instantly out of just, who knows. And several years of preparation and work were nixed in just a moment of not irrationality, but of unconsciousness. By the way, prayers work and meditations work, and the library is safely in the Getty. She did not understand the Getty is also associated with UCLA. And they paid nicely, and so most of those manuscripts are unique. The little triangular book by the Comte de Saint-Germain is hand-drawn. It was the only copy in the world. Many of the other volumes were extraordinarily rare. And Einstein and Bohr are interesting to us to begin science. And we'll come back to a farther reach when we come to Stephen Hawking and Roger Penrose, who are both still alive and still working here in the 21st century, who take Einstein and Bohr to about 1,000 times the mystery and interest and applicability. Penrose's last book is called The Road to Reality. It's about 700-800 pages. Sir Stephen Hawking is famous throughout the world as being the best-selling science author ever to live on the planet. But in between, Einstein and Bohr and Penrose and Hawking, who I'm pairing with Richard Feynman. Richard Feynman, the most humorous and outrageous artist outlaw after Einstein in science. And we'll have him and the other two together. But in between, I'm taking two women. And next week, for the next 4 weeks, we're going to look at the most scientific corn mother of all time, Barbara McClintock, whose work on maize over 50 years was the first to understand that genetic codes, corn has 13 chromosomes. She found that genes jump. They jump their place, jumping genes. There's a creativity that is a part of the design of the pattern. They're now called transposons. And the other woman is Vera C. Rubin, who's worked quietly in Washington, D.C. at the Carnegie Institute as a professor of astronomy. And she's the one who discovered and figured out that there's dark matter in the universe that dwarfs all the stars and galaxies that we can see. They constitute about 4% of what is real. Dark matter constitutes about 76%. And then there's dark energy as well. And it's Vera C. Rubin, who quietly is one of those great feminine heroes like Barbara McClintock, whose works, when paired together, show us something deep. There is more yet to be birthed in creativity than has happened yet. And one of the qualities that will come out of McClintock's work, she finally passed her last 20-some years of work with James D. Watson and his group at the Cold Springs Harbor Laboratory on Long Island, a stone's throw from the birthplace of Walt Whitman, and not too many miles from Brookhaven National Lab, where a lot of the nuclear work was done early in the 40s and 50s. But what will be important for us is to understand, right in the middle of the science phase, the relationalities that when you bring in all 8 phases together in our learning, you get something that Murray Gell-Mann called the Eightfold Way, the book that characterized quarks and the way that they work to make protons and neutrons, mesons, baryons, and to understand that that eightfold way, like the ancient eightfold path of the historical Buddha, like the 8 notes that make the octave of a musical scale, that this pair cubed, 2 times 2 times 2, makes a very interesting kind of a structure. And if you bring a resolving third into play, now you have 3 cubed, 3, 6, 9. Ancient wisdom has an alternating current of cubes of 3s and a direct current of cubes of 2s. And when you work with both those vector possibilities, scalars together, you get a ratioing which shows you a law called Bode's law of the way in which planets will position themselves gravitationally in that order where the cubes and the squares ratioed together will always give you a result of 1. And as long as you get the data correct, all the planets with all their complexities will turn out to be 1s in that resonant set of unity. That's what holds a star system as a star system. That gravity is a harmonic of the resonances of wholeness, not the integral of them. More next week.